This is question number 4, 620, paper 42, February, March 2024. The equation for the reaction between methanoic acid and this is the methanoic acid and ethanol in the presence of catalyst can be represented as shown. It shows it is an exothermic reaction because sign is negative. X represent the ester formed. In part A, question number 1, in equation, methanoic acid is represented by the formula HCOOH. Name the type of this formula. This is called the structural formula. Okay, write the empirical formula of methanoic acid. So first write the carbon. How many carbon atoms are there? Only one. Then we write hydrogen. So there are 2 hydrogen atoms and 2 oxygen atoms as well. So this is the empirical formula of methanoic acid. Name and draw the displaced formula of an ester. You know, in an ester, this part hydrogen is removed, and from here OH is removed. So the name of the ester is from alcohol. Alcohol is ethyl alcohol, so it is ethyl, and it is written as methanoic, so methanoate, ethyl methanoate. Oate is the suffix used for an ester. And now we have to draw the discrete formula of this ester. You know, here H, all the bonds are shown, and O, and this part comes from an alcohol. And in alcohol, there are 2 carbon atoms, 1 bond with oxygen, and there are 2 hydrogen atoms. And on the terminal carbon, there are 3 hydrogen atoms. So this is the displayed formula for this ethyl methanoate. The reaction is reversible and reaches an equilibrium with closed system. Definitely, equilibrium can be achieved only in closed system. Instead, what is meant by the closed system? So closed system is a system where no component or substance can enter or leave. Instead, 2 characteristics of equilibrium. If you think about the equilibrium, you know that in equilibrium, the rate of forward reaction is equal to the rate of backward reaction. And secondly, when equilibrium is achieved and the system is at equilibrium, the concentration of reactants and products and products becomes constant. although reaction is going on in both the direction. Now in this part of the question, complete the table 4.4 to show the effect, if any, on the concentration of X, means ester formation at equilibrium for each change of the condition. These are the four changes: 1, 2, 3, 4. So we have to note the effect on the concentration of X. Here was the formic acid, and then there was an alcohol, and that was the ester X plus water. And this reaction had delta H value in negative. It was negative 29.5 kilojoule per mole. 29.5 kilojoule per mole. So this was the equation. So what is the effect when temperature is decreased? So you know that this is an exothermic reaction. So the decrease in temperature uh, favors the reaction, and more X will be formed. So the concentration of X will increase because it is an exothermic reaction. Concentration of HCOOH, means formic acid, is decreased. So as much reactant is there, it goes to the forward direction and more product is formed. So the decrease in concentration will rate of decrease the concentration of X. So it decreases the rate of forward reaction and decreases the concentration of X. The concentration of both HCO3, HCOOH and ethanol are decreased. So they have the same effect because both of these are reactants, and the decrease in concentration of reactant decrease the product. If catalyst is removed, it doesn't cause any effect on the concentration, but rate of reaction decreases. So we are to ask the effect on the concentration of X. So there would be no effect on the concentration of X. Although removing the catalyst can decrease the rate of the reaction.